This is a problem on function. This is the given function. We have to find the domain of the function within the interval -1, 6. Domain of a function y equal to fx means the set of numbers from where x can be taken. Before solving this problem, I must clarify some important points. First, look at the intervals. This interval is given within parentheses. What does this mean? This means that this is a set comprising of any real numbers between a and b, excluding a and b. Sometimes the interval is given within square brackets. This means that it is a set comprising of all real numbers between a and b, including a and b. These intervals have a square bracket on one side and parenthesis on the other side. This means it is a set comprising of all real numbers between a and b, including the number written beside the square bracket, but excluding the number written beside the parenthesis. If there are braces, then this does not mean any interval. Braces mean that this is a set containing only these two numbers and no other numbers. Now look at the function carefully. The function has trigonometric function cos x. Whenever there is a trigonometric function, we should keep in mind that the domain of the function will have real numbers, as is the case for all real valued functions. But the real numbers should be considered as radians. In this problem, the interval is -1, 6. Now -1 is equal to minus 0.318 pi radians, and 6 is equal to 1.91 pi radians. So the interval can be rewritten like this. We have to find the domain of the function within this interval only. Now look at the function. This denominator cannot be equal to 0. Therefore, there may be two cases only. Case number 1, cos x minus half is greater or equal to 0. In that case, denominator should be greater than 0. This means 6x squared minus 35x minus 6 is less than 0. After simple factorization, it becomes x minus 6, x plus 1 by 6 is less than 0. Solving this type of quadratic inequalities is very easy. When x minus a, x minus b is less than 0, then x lies within interval ab within parentheses. When x minus a, x minus b is greater than 0, then x lies in the union of the sets minus infinity a within parentheses and b plus infinity within parentheses, where b is greater than a. Now coming back to our problem, this inequality is solved like this. This interval is within the interval that is given, so we take it. Now let's think about this. For explaining this part, I am going to draw the cosine curve within the said interval minus 0.318 pi, 1.91 pi. Clearly, the shaded part has cos x greater than or equal to half, so this would be the domain. The final domain will be the intersection of these two sets, which is this. Case 2. Cos x minus half is less equal to 0. In that case, the denominator should be less than 0. This means 6x squared minus 35x minus 6 is greater than 0. Similarly, after factorization, it becomes x minus 6, x plus 1 by 6 is greater than 0. Or in other words, x must lie in this set. Now the numerator. We again take the help of the cosine curve. The shaded part has a value less equal to half. So the domain for the numerator within the given interval is this. Now the intersection of these two sets is obviously a null set. So no values of x satisfy the function within this interval if the denominator is negative. Therefore, the answer is the set which we got in the first case, which is this one.